So for this problem, what we're going to do is look at a classic mixture problem where we're going to create a trail mix from raisins and peanuts. And what we're going to do is use a table in order to organize the data, and from the table we're going to extract a single variable equation that we can solve for our unknown. So we have a hiking store is going to mix some gorp, good old raisins and peanuts. So they're just making trail mix, in other words. This is trail mix. To sell to its customers, determine the number of pounds. So there's the unknown, the number of pounds of peanuts worth $1.29 per pound. That should be mixed with 20 pounds of raisins worth $1.89 per pound to obtain a mix that will be worth $1.49 per pound. So we've got three things going on here. We have information about peanuts, we have information about raisins, and we have information about the mixture of those two things to create our trail mix. So when you do a table to organize this type of information, usually what you do for the rows is you identify the things about which you've been given information. So we have information about peanuts, we have information about raisins, and we have information about the mixture of those two things. And what we're going to do is use a table to catalog the information about each of those quantities. So what types of things do we know? We know pounds. So in the case of peanuts, we want to know the number of pounds of peanuts we have. So we have information about pounds. And we need a variable to represent the unknown quantity, the unknown number of pounds of peanuts. And I do not want to use an X or a Y. I'm going to use P for peanuts, pounds of peanuts. We also know information about the cost per pound of peanuts. So we have a cost per pound piece of information that's going to go here. And for peanuts, that's $1.29 per pound. And then we want to know, we're also going to want to know the value of the mixture. And the idea here is that even though we're not given this value information in the paragraph, we do know that the value of something is going to be equal to the cost per pound times the number of pounds. So to get the value of the peanuts, I would multiply the P pounds of peanuts times the cost per pound, so P times 1.29, which would give me 1.29P. Now for raisins, I actually know how many pounds of raisins I have. I have 20 pounds of raisins. I know the raisins are worth $1.89 per pound. And so the value of those raisins would be 20 pounds times $1.89 per pound, which is going to be $37.80. That's what that's going to come out to be. That's the value of the raisins. Take the total pounds times the number of pounds. And then the mix, they don't tell us how many pounds of mix that we have, but I can actually get that from here, because the mix, when I mix peanuts and raisins, I'm going to have P pounds of raisins mixed with 20 pounds of raisins. So there will be P plus 20 pounds of the mix. And we're told what we want the cost per pound to be. We want the cost per pound to be $1.49. And the value of the mix is going to be the total pounds of mix, which is P plus 20 pounds, times the value of the mix, which is $1.49 per pound. So I'm getting this cell right here by taking this times this to get this. And what we also want to recognize is that the value of the peanuts, right? The peanuts have a value right here, plus the value of the raisins have to add up to the value of the mix. So this plus this must equal this. So once I get this information in the box, then I can use this final column in this particular case. Sometimes it's not the final column, but in this case I can use this final column to get a single variable linear equation to describe my situation. I have $1.29 times P, dollars worth of peanuts, mixed with $37.80 worth of raisins, equaling a total value here of P plus 20 pounds of mix times the $1.49. And then I want to notice that this gives me a single variable P linear equation. So now I can solve it. So I'm going to take the $1.49 and distribute it into the parentheses using the distributive property. So I get $1.49 times P plus $1.49 times 20 is going to be $14.90 twice, which is going to be $29.80. 14.90, 20, yeah. And then I'll bring down the rest of my stuff, 129p plus the 37.80. And I want to get all the p's on one side and the not p stuff on the other. And I'm going to go ahead and subtract $1.29p from both sides, so I get a positive number over here. So on this side I'm going to have $1.49p minus 1.29p. Subtract this from both sides here, and then get the stuff without the p all on the left hand side. So I'm going to subtract the 29.80 from both sides, which will leave me with a 37.80 minus 29.80 on the left hand side. So 1.49p minus 1.29p is 0.2p, and 37.80 minus 29.80 is just 9. And then right here, to get the p by itself, I could divide both sides by 0.02, or what I could do that's probably easier is recognize the fact that 0.2 is really, if I say it correctly, it's 2/10. It's 2/10, which reduces to a fifth. So 0.2 is a fifth. So I could actually, instead of a 0.2 right here, I'll erase everything, of course. Instead of a 0.2, I could put a 1/5. And then to get p by itself, instead of dividing both sides by 0.2, I can multiply both sides by 5. So a fifth of 5 is just equal to 1, which leaves me with 1p, and 9 times 5 is 45. And this is really 45 pounds because we were determining the number of pounds of peanuts we needed. So it's a story problem, so usually you finish it in a complete sentence. We need 45 pounds of peanuts.